Right, in today's lesson we're going to start looking at differential equations. We're going to understand what form a differential equation takes and then go on to be able to find general solution of these equations, known as particular solutions, which satisfy given initial conditions. Right, so what is a differential equation? Well, a differential equation is, we've been using differential equations. For example, if you're given dy by dx equals 4x, we've got a differential equation. We know that the derivative of y is 4x. So using that, we can then go on and integrate to get our function in y. So we want to write a differential equation to model this situation. The rate of growth of a plant is proportional to the square root of the height x of the plant. And we can write this as dx by dt is equal to k root x. A differential equation is a relationship between two or more variables and one or more of their derivatives. The order of a differential equation is given by the highest derivative in the equation. Dy by dx equals x sine x is first order, and d2y by dx squared minus 6 dy by dx plus 9 equals 0 is a second order differential equation. However, we are only going to consider first order differential equations in C4. Differential equations, we can solve these by integrating. So if dy by dx equals f of x, then we can integrate both sides with respect to x to get the general solution. Y equals the integral of f of x with dx, which equals g of x plus some constant c. So let's have a look at an example. We've been asked to find the particular solution of the differential equation x squared dy by dx minus 3x equals 1 if y equals 4 when x equals 1. Right, so looking at this, we want to rearrange this equation so that we have dy by dx equal to x. So rearranging, I will have dy by dx equal to 1 plus 3x over x squared. And if I separate this fraction on the right, I will have dy by dx equal to 1 over x squared plus 3 over x. And if I can then write this as dy equals 1 over x squared plus 3 over x dx, and integrate both sides, which will give me y equals minus 1 over x plus 3 ln x plus our constant c. So we've been told when x equals 1, y will equal 4. So if I substitute these into my equation, I will have 4 equal to minus 1 plus 3 ln 1 plus c, which will make c equal to 5. I can therefore now say that y is equal to minus 1 over x plus 3 ln x plus 5. Sometimes the equation involves y's. So if dy by dx equals f of y, then we can say dx by dy equals 1 over fy. And integrating with respect to y gives us the general solution. X equals the integral of 1 over f of y dy, which is gy plus a constant c. Now, we're going to now go on and solve a problem. Been asked to find the particular solution of the differential equation dy by dx equals cos squared y, given that y equals 0 when x equals 4. Right, so we've got dy by dx, but on the right hand side we've got a function in terms of y. So if I write it as dx by dy, I can then change the right hand side to 1 over cos squared y, and then taking dy over, I can now integrate both sides and integrate the right hand side with respect to y. So this will give me x is equal to the integral of sec squared y dy, which is a standard integral and gives us that x equals tan y plus c. But we've been told that when y equals 0, x equals 1. So substituting these in, I'm told that 1 equals tan 0 plus c, which means that c is equal to 1. So now I have my function x equals tan y plus 1. Looking at a second example, we've been asked to find the particular solution of the differential equation 1 minus y dy by dx plus y squared equals 1, given that y equals 1 when x equals 0. So I want to rearrange this so that I have dy by dx on one side and my function in y on the right. So this will give me dy by dx is equal to 1 minus y squared over 1 minus y. And I can see on the numerator that I've got the difference of two squares. So I have 1 minus y, 1 plus y, all over 1 minus y. And these cancel out to leave me with just 1 plus y. So I've got a derivative of x on the left hand side and a function of y on the right. So if I change this to dx by dy, I can change the right hand side to 1 over 1 plus y, which I can now integrate. So this will give me, integrating both sides, x is equal to ln 1 plus y plus a constant c. And again we're told when y equals 2, x equals 0. So 0 equals ln 3 plus c, which makes c equal to minus ln 3. Right, so now I can write my function for x. I can now say that x equals ln 1 plus y minus ln 3, and using my log laws, ln 1 plus y over 3, and that means that e to the x is equal to 1 plus y over 3. Multiplying through by 3, I can now say that y equals 3 e to the x minus 1. Now, in Core 4 we very often get more problem type questions. So we'll go through an example here. A hot air balloon can reach a maximum height of 1.25 kilometres, and the rate at which it gains height decreases as it climbs. According to the formula, dh by dt equals 20 minus 16h, where h is the height in kilometres and t is the time in hours after liftoff. How long does a balloon take to reach a height of 1 kilometre? So we need to find t. Right, so using this information, I know that dh by dt equals 20 minus 16h. So therefore, if we need t, I can write that dt by dh is equal to 1 over 20 minus 16h. And if I integrate both sides, I can get a function for t. I can see that t is equal to, now if we look at the denominator here, I can see the derivative would be minus 16. So if I have minus 1/16 on the outside, then minus 16 on the inside, I can now integrate this quite easily. I can say that t equals minus 1/16 ln 20 minus 16h plus a constant c. Now, t is measured from liftoff, so we can now say that at time 0, h was also equal to 0. So this will help me find my constant c. So therefore, 0 is equal to minus 1/16 ln 20 plus c, which makes my c equal to 1/16 ln 20. Now, substituting this back in, I can work out what t is. I think I'll change colour so you can tell. So now I can say that t is equal to, I'm going to put my c first because it's positive, 1/16 ln 20 minus 1/16 ln 20 minus 16h. I can take out my highest common factor here. I've got 1/16, and using my log laws, I can therefore say it's ln 20 over 20 minus 16h. And this bracket here, I can simplify to give me ln 5 over 5 minus 4h. Right, so now we have been asked to find out how long it takes the balloon to reach a height of 1 kilometre. So when h equals 1, t equals 1/16 ln 5, which is approximately 0.10. There we go. Now I would like you to have a go at the following exercises. The miscellaneous exercise 7 is particularly important as these involve more of the questions that you may meet in Core 4 in the next couple of months. We shall be having a look at differential equations 2, and we'll be working through some longer problems following the next lesson.